Have you ever wondered how Mars, the red planet, came into existence? A riveting question indeed, and one that has captured the minds of scientists, astronomers, and space enthusiasts for centuries. This crimson globe, hanging in the vast expanse of space, is a world shrouded in mystery. Its formation, a puzzle that we're only beginning to piece together. From the time the first telescopic eye peered at Mars, it has been a source of intrigue and fascination. Its fiery red hue, its polar ice caps, and its barren, rugged landscape all whisper tales of a past waiting to be unraveled. But how did Mars come into being? What celestial events gave birth to this enigmatic planet? There are several theories that aim to shed light on the birth of Mars. Some scientists propose that Mars, like all planets in our solar system, was formed from the solar nebula, a cloud of gas and dust left over from the sun's formation. Over countless millennia, these particles coalesced, slowly and steadily building up Mars, layer by layer. Others suggest that Mars's formation was a more violent affair, involving colossal impacts and cataclysmic collisions. According to this theory, Mars was shaped by the chaotic dance of protoplanets in the early solar system, their gravitational tugs and shoves molding and sculpting the red planet. And then there are those who believe that Mars's formation story is yet to be written, that we are on the cusp of a discovery that could redefine our understanding of planetary formation. A theory that could finally unlock the secrets of Mars, the red planet's past, and perhaps its future. Each of these theories offers a tantalizing glimpse into the formation of Mars. Yet each one also leaves us with more questions than answers. The mystery of Mars is far from solved. But fear not, for we are on a quest to piece together the puzzle of Mars's past, to decipher the secrets etched in its crimson soil and icy caps. Join us as we journey back in time to the birth of Mars. Imagine the early solar system, a swirling disk of dust and gas. This was the stage set for the birth of our fascinating neighbor, Mars. The story of Mars's formation begins with a concept known as the nebular hypothesis. This theory posits that our solar system, including Mars, was born out of a nebula, a vast, primordial cloud of dust and gas. As the nebula collapsed under the force of its own gravity, it began to spin faster, forming a flat, rotating disk. This is known as a protoplanetary disk. Within this disk, tiny particles of dust and ice began to collide and stick together, forming larger and larger clumps. Over hundreds of thousands of years, these clumps grew into what we call planetesimals, the building blocks of planets. Mars, like its planetary siblings, began as a humble planetesimal in this cosmic construction site. As it continued to collide with other planetesimals, Mars started to grow. Its gravity became stronger, pulling in more material from the surrounding disk. Meanwhile, the intense heat and pressure at the core of the young Mars caused it to differentiate, that is, to separate into different layers. A dense metallic core formed at the center, surrounded by a rocky mantle and a thin crust on the surface. Over time, Mars continued to evolve, its surface being shaped by volcanic activity, impacts from other bodies, and perhaps the presence of liquid water. But at its heart, Mars remains a child of the solar nebula, formed from the same dust and gas that gave birth to our own planet. The birth of Mars, like the birth of all planets, is a testament to the power and beauty of the universe's natural processes. From a swirling disk of dust and gas, a world was created. A world that, despite being millions of miles away, is in many ways not so different from our own. From a cloud of cosmic dust and gas, Mars began to take shape. Mars, however, isn't just any planet. It's a world with its unique set of characteristics that whisper tales of a different formation process. Let's delve into some of these fascinating features that make Mars a planet like no other. First off, let's talk about Mars's size. It's only about half the diameter of Earth, which makes it a bit of a runt in the planetary family. But don't let that fool you. Mars packs a punch with its composition that's quite distinct from its bigger sibling, Earth. It's got a dense iron core, much like our planet, but its mantle is chock full of magnesium and its surface is rich in iron oxide, giving it that distinctive rusty red color we all know and love. Then there's Mars's thin, cold atmosphere, mostly carbon dioxide with traces of nitrogen and argon. Despite its thinness, this atmosphere is capable of creating weather, including those infamous dust storms that can engulf the entire planet. But the real showstoppers on Mars are its geological features. Take Olympus Mons, for instance. This giant shield volcano is the tallest in the entire solar system, standing almost 3 times the height of Mount Everest. Its formation suggests that Mars' lithosphere, the rigid outer layer of the planet, doesn't move around like Earth's does. This allowed the volcano to keep growing and growing, as there was no plate tectonics to disrupt the hotspot of magma. And let's not forget Valles Marineris, a canyon system that dwarfs our Grand Canyon. Stretching over 2,500 miles, it's the longest canyon in the solar system. It's thought to have formed as Mars cooled and contracted, causing the crust to crack and collapse. Indeed, Mars is a treasure trove of geological wonders that hint at a unique formation history. Its size, composition, and these outstanding features all point to a different process of formation from that of Earth. These unique features suggest a complex and intriguing history. Our red neighbor continues to captivate us with its mysteries, and as we explore further, who knows what else we might discover. Could a massive impact have played a role in Mars's formation? Let's delve into a fascinating hypothesis that might answer this question: the giant impact hypothesis. This theory suggests that a celestial body, perhaps as large as our own planet, collided with Mars in its early formation stages. This colossal collision, according to some scientists, could be the reason for the stark differences between Mars's northern and southern hemispheres. To understand this theory, we first need to grasp the magnitude of the event we're discussing. Picture this: a celestial body, perhaps an errant planetoid or a massive asteroid, hurtling through the cosmos at unimaginable speeds. Its trajectory? A collision course with the infant Mars. Now, the impact from such an event would be cataclysmic, to say the least. It would have unleashed energy on a scale that's hard to comprehend, sending shockwaves rippling across the Martian surface. This could have resulted in a dramatic reshaping of the planet's terrain, potentially explaining the stark contrast between the smooth, lowland plains of the northern hemisphere and the craggy, high-altitude southern hemisphere. This theory is not without its evidence. Observations from various Mars missions have shown a noticeable difference in the thickness of Mars's crust between the northern and southern hemispheres. The southern crust is significantly thicker and more elevated than the northern one, which is consistent with the aftermath of a massive impact event. Moreover, the Borealis Basin, a vast lowland region spanning the northern hemisphere, has a shape that some scientists believe could be the result of such a catastrophic event. This basin, roughly the size of Asia, Europe, and Australia combined, could be the scar left by this colossal impact. But let's not get ahead of ourselves. While the giant impact hypothesis is compelling, it's just one of many theories proposed to explain Mars's unique characteristics. There's still so much to learn about our enigmatic neighbor. The scars of such a cosmic collision could still be visible today. So as we continue our journey into the cosmos, we keep our minds open, our curiosity piqued, and our sights set on the endless mystery that is Mars. The truth about Mars's formation is still shrouded in mystery. This statement is as intriguing as it is factual. Today we've taken a journey through our current understanding of how the red planet came to be, from its tumultuous birth to its unique characteristics, and the impact theory that might explain its formation. Each theory we've explored offers a piece of the puzzle, contributing to the larger picture of Mars's genesis. The birth of a planet, as we've seen, is a cosmic event that is both violent and beautiful. Propelled by the force of gravity, dust and gas swirling in the early solar system began to clump together, forming Mars over millions of years. Yet, Mars is not merely a smaller version of Earth or Venus. It has a unique set of characteristics that set it apart. With a day length almost identical to ours, a tilt that gives it seasons, and the largest volcano and canyon in the solar system, Mars is a planet of extremes. But it's the impact theory that has truly captured the scientific imagination. This theory suggests that a colossal impact with a body half the size of our moon may have resulted in Mars's current state. This could explain its smaller size, thinner atmosphere, and perhaps even why it's not as geologically active as Earth. Despite these compelling theories, the truth about Mars's formation is still out of reach. Our understanding of the red planet is still evolving, teetering on the edge of the next great discovery. Scientists around the globe continue to study Mars, using ever-advancing technology and planning future missions to further unravel its mysteries. The Curiosity rover, Mars Reconnaissance Orbiter, and future missions like Mars Sample Return are all part of this ongoing quest for knowledge. They are our eyes and ears on Mars, helping us to understand the intricacies of this enigmatic planet. As we continue to explore Mars, we inch closer to unraveling the secrets of its birth. This journey of discovery is far from over. Every new piece of information brings us one step closer to understanding Mars, our intriguing neighbor in the cosmic backyard.